Last week, we focused on sketching for exponential and logarithm and also solve equations and inequalities for exponential and equations for logarithm. As I said, to solve exponential, we need to make either both sides to be the same base or both sides can't have the same base. For example, they have base 3 on one side and base 5 on the other side. If we solve inequality, we need to use log to help us to do that. And for log, when we solve the equation, we need to remember to substitute the answer back to check whether that solution is within the domain or not. One question we did somewhere here, we sub x equals to minus 2 into the equation and we find the domain is negative and is not really within the domain. So we reject one solution. But before you reject it, you still need to write plus minus 2 and then make a short discussion why we reject it because of the domain. So we reject negative 2. So that's something we need to be aware of. And also solve inequalities for exponential. We better make both sides to be number larger than 1. For example, if you can make base a third or 3, we'll choose 3, not a third. Because if you make the base in between 0 to 1, the inequality sign will swap, will flip the sign to compare when we compare the power. So that's something we need to be aware of. And this lesson, we'll talk about like determine the rules and from the graph or from like points given. So for the first question, find the values of a and b such that the graph of y equals to a times e to the power of bx goes through the points 3, 10, and 650. Okay, for equation like that, we know like it's just basically substitution, but it's a little bit different when we solve for exponential. Okay, normally we do elimination or substitution when we're trying to solve simultaneous equations, but for exponential, it's a little bit different. Okay, let's sub in the point first. So 10 equals to a times e to the power of 3b, and the next point gives us 50 equals to a times e to the power of 6b. Okay, obviously we can't subtract them. Okay, we can't do elimination, we can't subtract, because exponential subtract another exponential not going to give you any new formulas. So for exponential, instead of doing substitution or elimination, we'll do division. Okay, we'll divide between two functions. We'll use number 2 to divide number 1, or you can do the other way around. So 2 divided by 1, left hand side we have, well, let's write it that way. 50 over 10 equals to a times e to the power of 6b over a times e to the power of 3b. So left hand side we have 5. And right hand side, this a and a will get cancelled. Okay, when we divide to exponential, what we do to the power? Minus or divide? Minus. Okay, we minus the power, so it's e to the power of 3b. Okay, it's e to the power of 3b. Okay, solve for exponential, that's what we learned last lesson. Solve for exponential. So both sides can't be the same base. 5 and e can't become the same base. So we use log to solve for it. Because we solve for power, we use log e 5. Okay, for log e, okay, base log base e, what's the other notation? What we can also write? On your calculator, that's on your calculator. ln, okay, ln. So that's equivalent to ln 5. Okay, on your calculator, you can see on the left hand side, there's a button like it's ln. That's log e. Okay, that's log e. Haven't emphasized that before, so just let you know now. So you can use ln 5 as well. Okay, log e 5. And b is equals to a third log e 5. Okay, b is a third log e 5. Okay, we find b, then we're trying to find a as well. Okay, trying to find a as well. So we can sub b into any equation now, like to find the value of a. So we sub b equals to a third log e5. Well, you can write log 5 as well. I'll sub that into equation 1. Okay, if we sub that into equation 1, we have 10 equals to a times e to the power of 3b. So 3b is just log e5. Okay, 3b is just log e5. b is a third log e5. So e log e5. What's e log e5? What's e log e5? E to the power of log e5. 5. Okay, 5. A log ab equals to b. That's the equation formula we have above. Okay, you must remember that a log am equals to m. We use that to differentiate exponential when the base is not e. So we change number to a base e. So that's the formula we have. Let's go back. So that's a 5. So 10 equals to 5a. So a is 2. Okay, a is 2, b is a third log e5. Okay, we already answered the question. Okay, we already answered the question. But I want to do an extra step. I want to sub a and b back into the equation and see what the equation looks like. So let's do one more step to substitute. So y equals to 2, okay, exponential bx. So remember what's b? b is a third log e5 and times x. Okay, that's why I sub a and b into the equation, what we can see. So after we sub in that, okay, obviously we can see this is not really nice, not really looks nice, and we can absolutely simplify that further. So what's the way we can simplify it? Is y equals to 2 times e. Okay, because a log am can be simplified, so I will put e log e5 here and then make it to a further power of a third x. Okay, because we go a to the power of m and then to the power of n, that's the same as a to the power of m times n. So we have a third x times log e5. We can use the formula backwards to make it log m and then a to the power of m and then n. So inside we have just a 5. Okay, that's just a 5. So that's 5 to the power of x over 3, or say a third x. Okay, 2 times 5 to the power of a third x. And if you can think about the equation, what's the graph look like? We have x and y, and also we have 0, 2. No reflection at all. So sub 0, we have 0, 2. Increasing function above the x-axis. No reflection, so the graph will look like this. I can put another point, maybe like, you know, like 310 is a point on the graph, so we can just put 310 there. Okay, that's for example 1. Okay, that's for example 1. For exponential, substitute values into exponential, we need to divide the two equations. Okay, we're trying to do division between the two equations to solve for it. Any questions to that one? Okay, this question itself is not hard. It's only a little bit tricky for the solving. And the second thing is, how do we do all of this simplification? The simplification is very important. How we can simplify the thing into the simplest form. Okay, let's have a look at example 2. For example 2, the points 310 and 512 lie on the graph y equals to a log e, x minus b plus c. Then the graph has a vertical asymptote with equation x equals to 1. Find the value of a, b, c. Okay, before we start doing this question, let me ask. When you know the vertical asymptote is x equals to 1, okay, what value you know immediately? B. Okay, what b equals to? 1. Okay, b equals to 1. According to the asymptotes, we know b equals to 1. That's easy. We can see that from the question. But if I change the question a little bit, I said prove b equals to 1, what you should do. Okay, if I change the question, ask you to, well, you can't answer directly b equals to 1. Well, if I said prove b equals to 1, what you should do? Well, I believe everyone can find out b equals to 1 according to the vertical asymptotes. But if I change the question to prove, okay, prove means you need to write all the steps to find b equals to 1. So what we should do? Any ideas? X minus b equals to 0. Good. That's the way we find asymptotes. Okay, assume we don't know what's the asymptotes. We're trying to find asymptotes. We make x minus b equals to 0. Okay, remember we can't use the fact that b equals to 1 directly. Proof needs to show the answer in the end. Okay, your last line needs to show b equals to 1, not in like previous lines. So x minus b equals to 0. X equals b is the asymptotes. Okay, x equals to b is the asymptotes. And also because x equals to 1 is the asymptotes. Therefore, b equals to 1. Okay, that's how you should make the discussion. I know you can see the answer directly, but you should understand how to write a proper proof. And also, if the bracket is much complex than this, so you also need to remember how to find the value of b. Okay, so if give you, for example, 2x minus b equal 2x minus b is the bracket, and tell you x equals to 1 is the vertical asymptotes, what we should do. So that's the same process. Okay, we find b equals to 1. Okay, we find b equals to 1, and then we can do the substitution. Okay, we can do the substitution. Y equals to a log e x minus b plus c. Okay, that's what the equation becomes now. We can sub the point 3, 10. Okay, 10 equals to a log e. 3 minus 1 is 2, and plus c. And 12 equals to a log e, 4, and then plus c. We said that equation 1, and that's equation 2. Okay, what you should do to solve for it. Okay, how we can solve for the value of a and c. Have two variables and two equations. We can definitely solve for it. What we can do. We add two functions, we subtract two functions, we divide them, or we times them. What operation we should do? Anyone give me a guess? We have the plus c and plus c at the back. Subtract. Okay, because we have the plus c and plus c here, well, that's one of the reasons we should subtract. We want to eliminate one variable first. Okay, that's the way we can eliminate one variable. So 2 minus 1. We do 2 minus 1. We have 2 on the left hand side, and we have a log e4 and minus a log e2. Okay, the c value will just be cancelled. C minus c is a 0. Okay, further solve for it. 2 equals to a. If I make a bracket, that's a log e4 minus log e2. When you minus 2 log, what will happen? Divide what? Yeah, the number in the bracket. Good. So when we minus 2 log, it's not become divide the 2 log. It will be divide the number in the bracket. So we have 2 equals to a log e, 4 over 2. Okay, 4 over 2. Okay, therefore a equals to 2 over log e2. Okay. 4 divided by 2 is 2, so a equals to 2 divided by log e2. Okay, I'll leave the answer like this first. And we go to solve for C. We're going to solve for C. So sub A into any equation, maybe sub into 1, sub into the smaller one. We have 10 equals to A is 2 log E2 times log E2 plus C. 10 equals to 2 plus c, and c equals to 8. Okay, we already solved our B, A, C here. Okay, B is here, A is here, and C is there. We answered the question already. But again, I want to find the equation, like what's the actual equation. Let's sub all the three values in. Okay, let's sub all the three values in. Also remember to read the question carefully. Okay, this question is ask you what's A, B, C value. When you answer the question, you need to list out what's A, B, C value, not write the whole equation out. Okay, not give a final answer like y equals to blah 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 and then ask me to find what's A, B, C. Okay, I'm not going to find it for you. So when it asks A, B, C, you need to give B, A, C value like explicitly out. So well, this is the extra step. Let's just find the equation. Okay, what's y equals to? So y equals to 2 times log e 2 times log e x minus 1 and plus 8. Okay, let's look this equation here. What simplification you can do? But if I ask you, you must do something. Well, it's alright to keep the answer like this. Nothing wrong with it. But if I really ask you to do something, what do you do? Any formula. Use any formula for log. I heard it. Wait. Change of base. Okay. I can use change of base. That's 2 times log e x minus 1 over log e 2. Okay, when two log divide each other, also they share the same base, we can use the change of base formula backwards. Okay, what that will become? What's this thing will equals to? Okay, 2 times log what? What's the base? 2. And we have x minus 1. Good. Okay, 2 times log 2 x minus 1 plus 8. Okay, so that's the simplest form I can see. Okay, it's actually not a log with base e, it's actually a question with base 2. Okay, but the graph won't have much difference. Okay, it's still like that shape. Okay, still that shape. Log base e, log base 2, same number. 2.7 for 2.718 for E and 2 for this new one. So graph won't change. Alright, that's for the log question. Okay, you have a log formula and you're trying to solve for a log equation, and the first one is for exponential. Alright, let's do last one for exponential. Okay, this is exponential graph and give you the form a times e to the power of minus x plus b. Okay, what b equals to? By looking at the graph, what's b equals to? That's so obvious. 500, thank you. 500. Okay, asymptotes is the b value, so b equals to 500 due to asymptotes. So b equals to 500, and what I have is fx equals to a times e to the power of minus x plus 500. Well, the only thing you need to learn from this question is asymptotes will give you the constant value. Okay, asymptotes will give you the constant value. So that's 500. And I just left with one variable and I want to solve it by substitute the point. Well, only point I have is 0,700. So I sub 0,700 into the equation. I have 700 equals to a plus 500 and a equals to 200. So fx equals to 200 e to the power of minus x and plus 500. That's a very simple question. Okay, it's just want you to see the horizontal asymptotes will give you the constant you add at the back. any questions for that page? Okay, if you don't have any questions, can you go to the last page for me? And I'll give you 10 minutes to sketch those two graphs. Well, 10 minutes is too long. 5 minutes. It's a exponential and it's a logarithm. We can do that really quick. Okay, I'm trying to draw that to scale. Okay, not really like accurate, but like kind of like, for example, 3 point something, you draw it above 3. So trying to use a ruler to sketch it to scale, because we're trying to see the inverse. Okay, we're trying to see the inverse on the same set of axes. So draw 1 and 2. Well, we have 5 minutes to do that. If you have you finish that early, you can find the inverse for me for those two equations. Okay, for the first one, well, as I discussed over there, like what we compare y equals to x. Why we compare with y equals to x? Because, okay, if it's below y equals to x, then it will intersect with y equals to x somewhere later. Okay, we want to see whether there's one more intersection or not. We know there will be intersection at the point 0, 0, right? Like, because it's already passed through 0, 0. So on the inverse function, 0, 0 is always also another point. But do we have another one? Do we intersect again, like further, like later? We won't, because we have this graph here and it's only touched the y equals to x at the point 0, 0, and there's no other like intersection after that. It increased so fast, okay? It increased so fast. It will be even steeper compared to this. Okay, when we deal with inverse questions, we know this one, we have, like, see the blue graph. Y equals to -1 will be the horizontal asymptotes. And then you know on the inverse, y equals to x equals to -1 must be the asymptotes for the inverse, right? If you have a horizontal asymptotes, you must have a vertical asymptotes on the inverse function. So we have the pink asymptotes, x equals to -1 is for the inverse, okay, for the inverse. Also, okay, y equals to -1, x equals to -1. This point is -1, -1. The y equals to x must pass through this point as well, and also connect 0, 0. You can see this red line needs to pass through the 0, 0, and also needs to pass through the intersection between the two asymptotes. So there's the intersection and this point. We connected it, like that's the red line here. Okay, well, we can see the shape of the graph already. If we can think about the shape of the graph, okay, I use a pink color. It also must pass through the point 0, 0 and symmetrical. Okay, this is my log looks like. Okay, or it's more close to asymptotes. So also pass through the point 0, 0. Okay, so that should be the shape of the log. You know, exponential and logarithm, they are inverse functions. That should be the log. Okay, that should be the log. If we solve for the inverse, we swap x and y. X plus 1 equals to 10 to the power of 2y. 2y equals to log 10x plus 1. And y equals to 1/2 log 10 x plus 1. Okay, so this blue one is y equals to 10 to the power of 2x minus 1. And this pink one is y equals to 1/2 log base 10 x plus 1. And also you can see it makes sense because x plus 1 equals to 0 and x equals to -1 is the vertical asymptotes, and also there's no reflection, so the shape will remain the same as an increasing function and on the right hand side of the vertical asymptotes. So this graph will look like this. There's only one intersection at the point 0, 0 and there's no other intersections. Okay, so the domain, okay, let's say the domain for f is R, and the range for the original function f is -1 to infinity. Therefore, the domain for the f inverse will be -1 to infinity, and the range for f inverse will be R. Okay, you swap the domain and range But when you find the original function, you can see all the rest. Okay, you can see all the rest. Okay, any questions for the first one? Well, first one is still easy. The only hard thing is, do we have another intersection? Okay, we need to compare that with y equals to x. Why we have this conclusion? Because it's increased so rapid compared to y equals to x. So that's why we won't have another intersection. Only intersects at 0, 0 for this one. Okay, if we can see the second one, okay, the blue graph is the second one. So y equals to log e3 minus x plus 2. You know, like log base e is like increasing function, and because k equals to -1, we will reflect it by the vertical. So we have this shape. Okay, we have this shape. So that's the shape we have, and x equals to 3 will be the vertical asymptotes. Okay, x equals to 3 will be the vertical asymptotes. Because you have x equals to 3 as the vertical asymptotes, then the horizontal asymptotes must be y equals to 3, right? Y equals to 3 must be the horizontal asymptotes. Also, same thing. The two asymptotes intersect, the point is 3, 3. You connect that point with 0, you will have the line y equals to x as the reflection line. Alright, let's have a think about the point must be on the inverse. Okay, what point must be on the inverse? I'll use the pink color. Okay, first of all, this point must be on the inverse because that's y equals to x. Okay, y equals to x. So that point must be on the inverse. Another point. Okay, we have 3 minus a bit, comma 0. Then 0, comma 3 minus a bit, which is here. Okay, 0, comma 3 minus 1 over e squared minus a bit must be here. And another point. Okay, another point which is log e 3 minus plus 2. Okay, log e 3 plus 2. Well, the thing is, we can see this point must be below 3 because it's 3 minus a bit. But for 2 plus log e3, do you think that point is greater than 3 or below 3? Okay, that's something we need to decide because whether it's in this side or that side. How do we decide it? Why we test with 3? Because the asymptote is 3. We want to see whether it's on the left of 3 or on the right of 3. So what we can see is whether this point greater than 1 or not. Okay, whether this point is greater than 1 or not. We compare that. So log EE equals to what? What's log EE? What's 1? Okay, 1. So log E3, we compare that. What's E? E is approximately what? 2.7. Okay, which one do you think is larger? Log E 2.7 or log E3? Log E 3 or 2.7? Log EX is an increasing graph or decreasing graph? Log EX. You know the log function? Is that increasing? So we put a higher value 3 compared to 2.7. The y value should be larger or smaller? Larger. Good. So log EE is less than log E3. Okay, log E3, this 3 is larger than 2.7. It's like the x value. X equals to 3, x equals to 2.7. A larger x will give you a larger y for an increasing function. So therefore, 1 is less than log E3. So log E3 is larger than 1, right? Larger than 1. So overall, this thing is larger than 3. Okay, 2 plus log E3 will be larger than 3 because log E3 is larger than 1. Therefore, this point should be here on the right-hand side of the asymptotes. So we know that's an exponential graph. That's the shape of the graph. So 2 plus log e3, comma 0. Okay, can you see it's symmetrical? Okay, it's symmetrical. And it passed through the line y equals to x, the same point there, you have intersects there. And then we have 3 minus a bit, comma 0, we will have 0, comma 3 minus a bit. So that's the inverse function. And if you want to find the rule, let's talk about the domain and range. So the domain for function f is minus infinity to 3 exclusive, but the range for the logarithm will be r. So therefore the domain for the inverse will be r, but the range for the inverse will be minus infinity to 3. That's the domain and range. And last thing we'll do is to find the inverse equation. So we find the inverse equation, x equals to log e 3 minus y plus 2. Log e 3 minus y equals to x minus 2. 3 minus y equals to e to the power of x minus 2, and y equals to minus e x minus 2 plus 3. That's the inverse. Okay, that's the inverse. So y equals to minus e x minus 2 plus 3. When you sketch two equations on the same set of x's, you must label the graph, okay? Indicate which equation is which graph, okay? The pink one is exponential and the blue one is logarithm. You must label that. Okay, and you can see that's symmetrical above the line y equals x, okay? If you reflect it, that will be the same, so it's symmetrical. After you sketch the inverse function, you must see by yourself whether it's symmetrical about that line. If it's not, then which means you get something wrong. Alright, that's the end of the exponential and log topic. Okay, that's the end of the exponential and log topic. Tomorrow lesson will be revision. You'll bring whatever you need to do next lesson and finish up the notes. Recordings uploaded and homework, scheme of work is online as well. Okay, so finish up everything. We'll start application of differentiation next week.